population of 2 colonies of bacteria after T hours are given by the following functions, f of 1 and f of 2, and these are for all values of T greater than or equal to 0. We want to compare the two functions over time. And so what we can do is we can think about what is happening to the functions as our T values are getting bigger and bigger. In other words, what is the limit of our functions as T is approaching infinity? And we're thinking about that for both of our functions, f of 1, and what is the limit as T approaches infinity for f of 2. And so this is nothing more than a real-life situation where we'd like to know the horizontal asymptotes of each of our functions. If we're looking at a graph of our functions, right, we'd like to know what is the value at which our function is going to approach as T gets bigger and bigger. And notice, of course, that each of these rational functions has a degree in the numerator that is equal to the degree in the denominator. And so, from our past experience, we know that this is going to be a perfectly horizontal and flat asymptote. So, to look at the first function, t plus 9.5 over 0.004t plus 0.05, in order to find our asymptote, it would be helpful to simplify our function by actually doing the division. So I'll go ahead and make a little room for ourselves here. And this shouldn't be very hard. It's just a couple of decimals. But we'd like to divide t plus 9.5 by 0.004 t plus 0.05. I should make that a little clearer. There we go. Alright, so the first question we've got to ask ourselves is, well, how many 0.004 t's are going to go into 1 t? And for that, we can just divide 1 by 0.004, and you're going to end up getting 250. And when you multiply 250 by 0.004, you're going to get t. And at this point, you can kind of notice that whatever happens after this is going to be totally irrelevant. And here's why. When I subtract, notice that my t's are going to cancel, and I'm just going to get some whole number here. Well, that whole number is going to be our remainder because t will not be able to go into it. And as t approaches infinity, any remainder that we have, I'll just add it on here at the end, some number divided by 0.004 t plus 0.05, as t gets very, very big and approaches infinity, even though this is multiplied by a very small number, this is going to go to 0. And so I don't really care about it. I can just sort of forget it exists, and my limit for f of 1 as t approaches infinity is going to be 250. At this point, I want you to go ahead and pause, go ahead and find the horizontal asymptote for f of 2, and then when you're confident in your answer, think that it makes sense, check back, and we'll fill you in. So hopefully you did the same thing in noting that I'm looking for the horizontal asymptote, and dividing using the polynomial division algorithm will help us get a sense of what this will be. And what you should get is that the limit for f of 2 as t approaches infinity is just going to be 3 over 2, or 1.5. And so here we see a really drastic difference, right? For f of 1, our function is going to have a horizontal asymptote at 250, but for f of 2, we're going to be way down low at 1.5, and that's not even to scale, but it's even more drastic than that. And so for f of 1, right, I'm going to be getting closer and closer and closer and closer to it, and for f of, that was for f of 2, and for f of 1, I'm going to be closer and closer and closer and closer to 250. And so as time rolls on and it gets really, really large, our colony in f of 1 is going to become a lot larger than our colony in f of 2.